So the next item that I want to discuss is the manipulation of formulae. So this here is basically rearranging formulae. It's very, very important if you move on to Leaving Cert maths, physics, chemistry, any sort of more advanced course that requires you to be able to mix around equations in order to get certain answers. So when we're asked to get something in terms of something, say we're asked to get A equals 2B in terms of B, we basically want to write B is equal to some combination of every other variable and number that's in the equation. So in that case, if we want this in terms of B, we just divide on both sides by 2, we'll get this. That's that equation in terms of B. We want to rearrange y equals mx plus c, the equation of a line, to find x in terms of y. To do this, we're going to subtract c on both sides, so that removes this c here. These cancel out. We have a y minus c left over here. We're left with y minus c equals mx, dividing across on both sides by m, or dividing over by m, whichever you prefer, removes the m on this side, so this leaves us with x equals y minus c over m. That's all we need. X is on its own, everything else is on the other side. X in terms of y. Slightly more complicated example, this is the Newton's law of gravitation. We want to find r in terms of all the other variables. So what we do is we multiply on both sides by r squared to get rid of this bottom fraction. So in doing that, we get f times r squared equals g times small m times big M times r squared over r squared. So those r squareds cancel. Dividing by f on both sides, our f's cancel on the left. We then end up with r squared equals g times m times small m all over f. Finally, we're left with r squared equals g times big M times small m over f. All we need to do is take the root on both sides, and we're left with r equals the root of g times big M times small m over f. So we're given a equals p over p plus b. We multiply on both sides by p plus b. The p plus b on the right hand side will cancel, and we're left with a times p plus b on the left equals p. Multiply the a in, and you're left with ap plus ab equals p. Bring this p over on the right over to the left hand side. We're left with ap minus p plus ab. Bring the ab over the far side, factor out a p, and then divide across by minus 1. You're left with p equals ab over 1 minus a. Okay, so in this next example we have r equals the root of pq plus q. So when we're squaring on the right hand side, we're squaring the entire root as opposed to what's inside, as you usually would when there's no root. So then when we square both sides, we have r squared equals pq plus q. We can factor out a q because we have a q in both terms on this right hand side. We're left with r squared equals q times p plus 1. Dividing across by p plus 1, we're left with q equals r squared over p plus 1. Another example including roots is the equation of a pendulum in physics. So we'll want to find everything on one side and g on its own. To do this, we're going to square both sides, as in the previous example, so that leaves us with t squared equals 4 pi squared times L over g. We then multiply the g up onto the left hand side, leaving us with gt squared equals 4 pi squared L. All we need to do then is just divide across by t squared, leaving us with g equals 4 pi squared L over t squared. We have the volume formula for a sphere, v equals 4 over 3 pi r cubed. We want to find r as the subject. Again, that just means find r in terms of all the other variables. So what we have here is we want to divide across by 4 over 3. In doing this, that's the same as flipping it upside down and multiplying. So that leaves us with 3 over 4 v equals pi r cubed. Dividing across by pi, we have 3 over 4 pi times v equals r cubed. All we need to do then is find the cubed root on both sides so that we have r in terms of all the other variables.